All right, so in this video, we're going to go through sample question 58 from the Society of Actuaries ExamP list of sample questions. The question reads, a company insures homes in 3 cities, J, K, and L. Since sufficient distance separates the cities, it's reasonable to assume that the losses occurring in these cities are mutually independent. The moment generating functions for the loss distributions are as follows here. Let X represent the combined losses from the 3 cities. Calculate the expected value x to the third, e of x to the third. Okay, so this question is testing you on a couple of different things, mainly to do with moment generating functions. What is it testing you on? Well, this last line, asking us to calculate e to the third, right? The third moment of x. Well, one fact you should know, the nth derivative of a moment generating function evaluated at 0 is the nth moment. So since we're being asked to find the third moment, if we took the moment generating function of x, took the derivative 3 times, and evaluated at 0, we would find e of x to the third. All right, that's the first thing. The next thing is, okay, now that we know we need the moment generating function, how do we get it? Well, we're told that x represents the combined loss of all 3 cities. And because we're given this, the fact that they're independent, that's going to be one of the more crucial parts of this problem. X is equal to, and let's say J, K, and L represent the losses, right? X, the loss of all 3 cities combined, should just be J plus K plus L. Okay, so now let's find the moment generating function for x here, right? So a moment generating function is the expected value of e raised to the x t, right? Where this is equal to mt, as so. And then, since we're looking for the moment generating function of x, t should then be j, k, and l. So the expected value that we're looking for is the expected value of e to the x times, x is going to be the thing that's going to be j, k, and l, and that's multiplied by t. I misspoke. And then, yep, so j plus k plus l multiplied by t, right? We're just going to do that small replacement. Now, some of you might already see where this is going, but I'm going to do this line by line just for the purposes of the explanation. So expanding this out, we now have the expected value of e raised to the jt plus kt plus l t. And now, because they are independent, we are allowed to do the well, actually, I'm going to write one more line in between this. This is actually just some algebra. This can become e raised to the jt multiplied by e raised to the kt multiplied by e raised to the lt. Just like that. And because they're independent, we're allowed to do the following. Write them out as a product of each individual e term. So this should be the same as the expected value of simply e to the jt times e raised to the e of e to the kt multiplied by e of e to the lt. And here's the thing, we have each of these components, that's given to us. So now if I want the moment generating function of x, I just do a little bit of a replacement. Okay, so now we have 1 minus 2t to the negative third times 1 minus 2t to the negative 2.5 times 1 minus 2t raised to the negative 4.5. Now, we're in a very lucky situation. All of these bases are the same. So we can treat this as like an x raised to the negative third times x raised to the negative 2.5 times x raised to the negative 4.5. And that would just be x2, the sum of the exponents. So our base is going to remain the same. This is just a basic algebraic thing, a property of exponents. If your bases are the same, you can just combine them and add the exponents. And this should become 6, 7, 8, 9, 10. 1 minus 2t to the negative 10. And that is our moment generating function. Okay, so that's how we got that. Now that we have the moment generating function, we can do what I discussed earlier, which would be taking the derivative 3 times and then evaluating at 0. All right, so let us take the derivative. Now, this is going to require chain rule because there's no way I'm opening up that parentheses with a negative 10 as my exponent. So let's see. For chain rule, inside-outside term, it's going to be the derivative of the inside, which should be negative 2, multiplied by the derivative of the outside, so it's going to be negative 2, multiplied by negative 10, times 1 minus 2t to the negative 11th, which should then equal positive 20, 1 minus 2t raised to the negative 11th. Okay, now this stuff might seem trivial at this point. The actual probability part of it's done. This is just calculus, but I'll still do it again line by line just for the purposes of teaching. So once again, another chain rule. Derivative of the inside is still negative 2. Derivative of the outside is going to be, just making sure I don't make an embarrassing, negative 220. A negative 220 times 1 minus 2t raised to the negative 12th. Yes, because I don't have these done out beforehand. It's important for you to see my process. Okay, so that's the second derivative. And the third derivative would be, or actually this I should combine a little bit. So this should be positive 440 multiplied by 1 minus 2t to the negative 12th. And then one more chain rule on that, right? Derivative of the inside portion is still negative 2. Derivative of the outside portion is negative 12 times 440, which is a negative 5,280 multiplied by 1 minus 2t to the negative 13th. And this simplifies to a positive 10. Just going to quickly multiply that too. Okay, this becomes now positive 10,560 times 1 minus 2t to the negative 13th. All right, I'm going to write that over here just to make it a little more clear. So the third derivative of our moment generating function is equal to 10,560 times 1 minus 2t to the negative 13th. Now, if we want to find the third moment, all we do is evaluate at 0. The expected value of x to the third should be equal to our third moment of x evaluated at 0. And this is quick to see that this should equal 10,560. Answer choice E. All right, so this might seem like a complicated problem, especially because moment generating functions are, in my opinion, one of the trickier topics. On top of this, this is a multivariate problem. We have multiple moment generating functions to deal with. So the first step I took was, all right, the question's asking me, figure out what the question's asking me. It's asking me to calculate e of x to the third, right? Expected value of x to the third. And it gives me a bunch of moment generating function pieces of information. So based on that, I was able to relate, okay, they want me to calculate the third moment. I'm familiar with the rule that the nth moment is equal to the nth derivative of a moment generating function evaluated at 0. That's a very important rule. If there's anything you remember about moment generating functions, it's that rule. The other thing was rules of independence when you're dealing with moment generating functions. Okay, and that's where I was able to rewrite this and find the actual MGF of x using the MGFs of j, k, and l. And then after that, once I actually found the moment generating function, probability done, then it's calculus. Okay, if you have trouble on the chain rule is something, people forget. I have a video on that. It's probably way back if you just search. But that's pretty much it for this problem. If there are any questions, leave it down in the comments. I will answer to the best of my abilities. If you want to see more questions done out like this, I have a playlist, other ExamP sample questions. However, if you found this video helpful, hit the like button, subscribe, because that's definitely something I find helpful. Other than that, good luck.